Welcome to Lesson 14C, Practical Application, Jet Engine Afterburners, Part 2. Again, here's our special guest lecturer, Glen Coates.
This is Part 2 of Jet Engine Afterburner components. What I want to talk about is the fuel injection system and flame stabilization. Finally, the afterburner liner. It becomes a thermal barrier, and it's also good for noise suppression. And finally, we'll say a few words about the digital fuel control and how it's used to schedule the fuel flow and in coordination with the nozzle movement. And here's a picture of the entire jet engine with the afterburner shown. And I've labeled all the parts. Working across the bottom here, the digital engine electric control. Fuel injector tubes, that's where all the raw fuel comes in. Bluff body flame stabilizers, or sometimes called a flame holder. It's an intentional stall that's put in the fluid, and what it's intended to do is to hold a fuel-air mixture, having lit it once, and the lit fuel acts as a piloting source for the fuel once the afterburner is lit. Then there's the afterburner duct, and there's two functions for that. There's a liner in there that is a thermal barrier, and also it works as an acoustic barrier as well. And finally, the converging-diverging nozzle. Now for the fuel injection, that's done very simply by putting high-pressure fuel in a tube. You see the picture over on the right. It shows the fuel injection tube with 20 thousandths diameter orifices. And these are drilled into the fuel to atomize it as you get the high-pressure fuel going through there. And of course, the air continues to shatter the droplets into smaller combustible sizes. And then this is the flame holder. It's an intentional stall. It's a pressure loss. It's inside the flow path. And if you look at the top picture over here, you can see that flow comes in from the left to the right, and there's a recirculation zone right in the wake of this bluff body. Now what we've done is we have lit the fuel, and now it continues to burn as long as there's fuel coming at this thing. And what happens is there's eddies that shed from this bluff body. It's alternating hot and cold, and what ends up happening is that this is a piloting source for the rest of the flow field. And if you look down at the bottom picture, you can see that there's maybe for one instant there's flow going forward, and then there's flow going negative, and it alternates. This is a picture of flame holders that are used in gas torches. On the left is a common gas burner you may have used to light some charcoal. And now I'd like to show you an end view of a blowtorch. If you take a look at the picture on the left, it's a brand new nozzle assembly for a blowtorch that you might use to light charcoal in the backyard. And if you look at the end face of it, it looks like a screen type of affair. And literally what's going on there are stalls in the flow. That's where the thick walls of the screen, if you will, are. And flame gets held off of those surfaces. And then if you look at the right-hand side, this is another view of a different type of nozzle. And once again, you see a type of a flame holder at the very tip of the nozzle. It's a stall in the region, and it acts to recirculate the flow. If we look at the second picture over here, you can see the streaks in the flow here, which kind of indicate the presence of a flame holder there. And then the afterburner liner. This is at the aft end of the engine. This is a view of the entire jet engine focusing on the thermal liner in the very back. It has two functions. One, it becomes a thermal barrier protecting the titanium shield on the outside here. And then it also functions as an acoustic damper as well. So if you look at the cross-section up close, the hot afterburner gas is on the ID side, and there's a little bit of a pressure loss that's associated with the high temperature of that flow. And then on the other side, the south side of the drawing, there's cooling flow. It's discharged from the fan stream, and it's higher pressure. So what ends up happening is the high pressure cooling air leaks through several places on the liner and lays down a film of cool air to protect the engine case. Now in addition to the thermal function, there's also a function that this acts as a muffler. If you're familiar with Helmholtz resonators, there's a cavity over here between the engine case and the protective liner. And as the air goes in and out with the air pressure fluctuations, it tends to dampen the noise. And so this cavity over here, it's called a Helmholtz resonator cavity, and it is tuned to get rid of noise in certain frequencies. And then finally there's the digital engine electric control. A very important function that this thing serves, and that is to coordinate the opening of the nozzle with increments of fuel flow. What it means is if we put all the fuel flow in at once, if we turned on all these fuel injectors, you'd get basically a huge explosion in the back here, and you would tend to stall the engine. So the way this normally works is that the fuel is introduced in 5 or 6 increments, and with each increment of fuel being injected, there is a coordinated timed movement of opening the nozzle. And if it were done perfectly, then the pressure in the back here would remain essentially constant. So it has to be coordinated between when the fuel comes in and when the nozzle is opened and increased. And so here's the summary. The fuel injection atomizes the high pressure that's fed through those small orifices. And once the flow comes out of the orifice, of course, the air shatters the droplets into even smaller particles that can burn easily. Then there's the flame stabilization by a bluff body, and it induces a recirculation zone of burning gas and therefore acts as a constant ignition source. The afterburner liner, there's a thermal barrier for the engine case, and it also acts as an acoustic damper. And finally, there's the digital engine electronic control. It coordinates the movement of the nozzle with the afterburner fuel flow that's coming in, and the intent is to try to coordinate these such that there is not a significant change in pressure in the back end, because you don't want to stall the engine.
Thank you for watching this video. Please subscribe to my YouTube channel for more videos. 1, 2, 3.